Kate Stoll, Senior Policy Advisor at the MIT office in Washington, D.C. Kate. Next up, Ben Corb, Director of Public Affairs at the American Society for Biochemistry and Molecular Biology. Next, we have Dr. Adam Fegan, Director of the Early Career Scientist Segment at the American Association for the Advancement of Science. We're also joined this evening by Dr. Marnie Gelbart, Director of Programs at the Personal Genetics Education Project. And unfortunately, we are not joined this evening by Dr. Lisa Coleman, the Chief Diversity Officer at Harvard University. We were informed about 2 hours ago her flight from Virginia was canceled this afternoon. So she really regrets she wasn't able to join us. And last but not least, I'd like to welcome the co-founder of Academics for the Future of Science, who will join me as a moderator on this panel, Justin Taylor.
Hi, so I just want to welcome you all to the panel. Thank you so much for coming out. And I want to ask you just to introduce yourselves, give us a little overview of what you're working on, and some specific highlight of something you've worked on recently for science policy.
Go from your end to mine. Your end first.
Yeah. Here.
Okay, well, maybe starting with the person who may be the odd duck on this panel. Because in my role at the Personal Genetics Education Project, I actually usually think that we are not specifically advocating for science, but rather that we take a neutral position about where genetic technologies are going, and that we're raising public awareness about where those technologies are going, both the benefits and the implications. And so that the one thing we do advocate for is awareness and conversation, and that conversation is as inclusive as possible for all individuals, regardless of socioeconomic, cultural, educational, religious, or ethnic background. I would say that a most fortunate consequence of that is I think it does reflect very well on science, that people become more interested, to know more, to be more engaged. In our work, we visit high school classrooms, and teachers report back to us, or when teachers use lesson plans that we write, they report back that some of these topics are ones that stick in their students' minds, and these are the things that they talk about when they go on college interviews, that these are problems that are inspiring kind of this next generation, and maybe think about careers in science, both that are what we might think of as traditional careers in science, but also in fields like policy, education, law. And so I would say, so we are based in the Department of Genetics at Harvard Medical School. We exist, when I joined pgEd 5 years ago, was one of the first paid staff at pgEd. We've existed for about 10 years. And the reason that we exist in the Department of Genetics is that our chair, Cliff Tabin, felt that as part of the researchers that are advancing genome sequencing, other genetic technologies, that the department had a responsibility to be engaging the public and to hearing from the public their feedback and integrating that into the department's work. So the gap between what we in the science community know and what the public is aware of, I don't think surprises anybody here to know that it's huge. But I will say that at pgEd we visit communities, all sorts of communities, both well-served and underserved communities, and that what we find often or particularly, I should say, in well-served communities, certainly not, these are not fully representative, but that there are people who are availing themselves of genetic technologies, heard of what's going on, participating in research. And it's sometimes that when we visit underserved communities that we hear comments that I would say when I was a researcher and I was a graduate student and a postdoc in genetics, that we hear statements that I hadn't really heard before. We'd hear somebody say that you mean to tell me that my mother, who doesn't have health insurance, but pays her taxes, that it's going to support the research that you all are doing, and she's not going to directly benefit from it? That I'm not concerned about what diseases I might develop when I turn 65. I'm worried about my kids, that that I'm worried that they may, get shot or stabbed. And I just want to make sure that they live to see their 20s. And how come no one in my community knows that all of this is going on? And so I think that informs a lot of what we do, that the size of the gap is much bigger than we often think about. And so we go to communities, and do I have time to continue at this pace? So that we visit high schools, we visit libraries, museums, we write curriculum, we train teachers. Most recently, we're beginning to work with communities of faith, as what a lot of this comes down to is issues about trust, and that communities of faith are places of trust. And partnering with these communities, we hope, is an opportunity to talk about both the benefits and the implications. We talk about the really sticky issues in genetics, but that seems like it's the place where the conversation starts, not the facts about genetics that I personally love and have loved for a long, long time. That is not where the conversation begins, but that if we really talk about these sticky issues, that we find that people lean in, get really involved, that you do not have to have a sophisticated level of knowledge about genetics to be able to engage in really high-level conversations about how we should or should not use genetic technologies. So we also think a lot about scale. We work with writers and producers of television and film. We collaborate with two organizations, Hollywood Health and Society at the University of Southern California, and the Science and Entertainment Exchange, which is a program of the National Academy of Sciences, and able to work with writers and producers who are developing storylines and who are very interested. They see a lot of genetics in the news, gene editing being a recent topic of great interest, and want to bring that into their storylines. So we've advised shows like Grey's Anatomy and Elementary. We've been working with writers and producers, most recently on a feature-length film script that just got picked up and is going into production soon, so that's very exciting. And I think we're getting to the point, we've been asked a lot, can you help me, by writers and producers, can you help us use genetics to kill off a character on our show? It is time for him to go. Help us do it. And we are coming to the point now where we have the opportunity, where we're developing a core group of writers and producers who are really interested in helping to depict geneticists as people who want to help, and that there's an opportunity, not just this dystopic vision that we often hear about. And so I think there's something really exciting that's happening there. And then the last place I'll say is that we also are holding a series of congressional briefings. So we do go to Washington, D.C. I have the least experience in Washington, D.C. of anybody sitting up here. We went to D.C. We thought we were going to have one briefing on genetics, where technology is going, the importance of raising awareness. We heard that if we had 26 people who stayed for an hour, we'd be doing well. We had 65 people, stayed for an hour and a half and more, so we were really excited about that. We were invited to come back and do a full series that explored issues more deeply. We're hosted by Congresswoman Louise Slaughter and Senator Elizabeth Warren, and we now have done 5 briefings. The last 2 were on gene editing and also the intersection of genetics and space travel, have really filled the room, 180 people or more, and have really brought in both people from both sides of the aisle, which is really important. So I will say that what we go to DC to do is really advocate for awareness. We go there for the conversation, and I think that as you all think about what are the ways to contribute to this sort of advocacy, I think engaging with the public with no other motive except to raise awareness and have a conversation is a really important part of that.
Thank you so much. Go.
Hi, once again, I'm Adam Fegan. It's nice to be back here in Cambridge. It was far too long ago that I was in grad school just up the road here. And that was really, I think, the place that I first got involved with advocacy. And I think one of the points that I wanted to mention is it happens at a lot of different levels. So, there's the level of Congress, but as we heard, from the Graduate Student Council, they're advocating things that are national and international, but also things that are very local. And those kinds of skills and experiences are probably easier to make a difference in, but they also provide the right kind of training and experience if you're interested in pursuing this kind of thing more seriously as a career. I know when we've hired people in these roles, trying to find what are those examples of ways that you've been involved with really trying to make change at any level. So that was kind of my experience. I first got involved really at a local level. I was the president of the Graduate Student Council at Harvard for a couple of years, and it kind of gave me an insight into the process of really trying to make change and work with disparate partners and try to appeal to sort of the interests of whoever you were trying to deal with. In our case, it was, the graduate school and trying to, help them do their jobs more effectively. It also provided me an opportunity to get involved with some national efforts. There was the National Doctoral Program Survey, which was launched about 15 years ago now, which was program by program assessment of doctoral programs, trying to determine to what extent they were consistent with best practices. And that kind of gave me some of that exposure nationally, because there were a lot of conversations happening at the time about graduate education, and me as a graduate student actually had the opportunity to participate in some of those, and discovered that even though we were talking about graduate education, I was often the only or one of only a small handful of people in a large room talking about these kinds of issues. So when I finished up my graduate training, I went first to the National Academy of Sciences, where I was on staff, worked on a whole bunch of different projects, but the first one, and in a way the one that probably still remains closest to my heart, was a report that was issued, I think, back in 2005 called Bridges to Independence, which was one of the things that convinced NIH to launch their K99R00 Pathway to Independence Award. It was all about trying to foster independence in research among early career scientists. And, it was an opportunity to really kind of see that, sometimes these kinds of things might actually, happen. After about 7 years there, I went to the American Society of Plant Biologists, where I was the director of public affairs, where I worked on policy, on education, and on communications. And then I had the opportunity to come to the Genetics Society of America, where I was executive director for about 5 years. Had the good fortune to work a little bit with Marnie. I know Gary was one of our members. And one of the things that we really tried to focus on there was, I think, engaging the next generation, engaging our graduate student and postdoc population. When I left GSA, the student and postdocs were more than half of the membership of the society, and a really important segment of the future of our community. But we really worked to really try to engage and give a sense of ownership and leadership to members of our student and postdoc communities. One of the folks that we had as a representative to the GSA board helped organize this, Sonia Hall, sorry to call you out, about that. But it was really an opportunity to try to transform a bit of an organization from the inside. Just about 6 weeks ago, I moved to AAAS, where I'm hoping to do some of the same kinds of things there with a much larger community, which is to really help engage folks early in their careers in the society, and helping AAAS do more of the kinds of things that we do, give you more of a stake and more of an involvement. Advocacy is one of the important areas that AAAS focuses on, and maybe later, happy to talk to you about some opportunities for folks to participate in some of those activities. And I think, again, folks relatively early in their careers tend to have the most at stake for the future of science. And so in a way, you're some of the most compelling messengers about these kinds of things. It's easy to feel like, well, I'm relatively young, I don't know what I'm doing. But as you look to, what your career is going to look like, in a way, you're a lot better of a spokesperson than somebody who's nearing the end of their careers. Maybe I'll leave it at that, and we can come back during the discussion and fill in some other things.
Thank you.
Good evening. I am Ben Corb. I am the Public Affairs Director for the American Society for Biochemistry and Molecular Biology. If you're in the audience and you're wearing a riffraff shirt, yeah, it was my president that called you riffraff, and no, that wasn't my idea. And yes, I'm sorry. I'm an advocate. I do this on the daily basis on behalf of the life science community. I studied political science in college, which makes me a scientist in the way that Dr. Seuss is a doctor, so I guarantee you that you all are smarter than me. I'm sure you're going to come up later and tell me that. I will say just briefly, that opening used to be, makes me a scientist in the way that Dr. Pepper was a doctor until somebody came up to me and said, Dr. Pepper was a doctor. I was at a board meeting and decided to try to use the cell, a eukaryotic cell, as an example of the federal government, and talked about the ribosome and the size of the ribosome inside the cell representing the size of the science budget and blah, 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 until the president of my society interrupted me to say, actually, I do research on ribosomes, and many of us believe that all the ribosomes in the cell are connected and therefore much larger than you're depicting it as. And I decided I am not a scientist, so I will tell you all from the very beginning. Very briefly, career-wise, I've been a science advocate for more than a decade. I've been with ASBMB for 6 years. Before that, I did advocacy work for biomedical engineering. And before that, I did advocacy work for the aerospace community. So I have worked with rocket scientists and brain surgeons and have surrounded myself with really smart people. In terms of successes, there's a saying in Washington which is that success is the child of 100 parents and failure is an orphan. So I would gladly sit here and tell you that the NIH got a $2 billion increase last year, and that's entirely because of me. But you may say that too, and that would be entirely accurate as well. I'm going to go back to a more macro issue that we got involved with. It was referenced earlier, the sequester in 2011. The creation of the sequester caused kind of this fiscal crisis and this problem of dealing with what the impacts of sequestration were going to be. If you listened to the president, you would believe that the sky was going to fall, that airplanes would fall from the sky, and dogs would meow and cats would bark and the world would end. If you listened to Republicans in Congress, they would tell you that nothing is going to happen because the government doesn't do anything of any import, and so this budget is small. And if you had 5% less of your budget, you'd be okay. Why can't the government work in the same way? My society decided to take a different tact, which is we actually met with other scientific societies and recognized that science is kind of a special animal. It's not like a road construction project, which is critically important, particularly if you're in Boston or live anywhere between Boston and Washington, D.C. and drive on a road. You know road construction projects are important. But with a road project, you can, when you don't have money, you can put cones around the project and you can create a traffic jam, but you can get back to it when you have money. Science doesn't work that way. When you run out of money, the experiment stops. You know, your cells die, your cultures don't work, the people working in your lab move on to other labs and do other research. Really, it kind of ends. And so we needed to find a way to depict how science was different and what the impact of a budget cut or a cap on discretionary spending would have in the scientific community. So we worked with 16 different societies, and we polled their members and asked them a series of questions about what the impact of sequester was going to be. This was not a scientific survey, it was a survey of scientists. So the data that we presented could not be properly extrapolated and yada, yada, yada. But it really made a point. And the point was that the scientific community was really feeling the crunch on not only sequester, but also kind of a decade of really kind of difficult fiscal environment. We found that 1 in 5 scientists were looking to leave the country, or at least considering leaving the country to do research in other places because of the kind of fiscal constraints that existed in America. We found that 80% of the people that we talked to knew of a colleague that either had to shrink the size of their lab or were shutting down the size of their lab. We came up with lots of these talking points, and we decided not to publish them in some scientific journal or to go to Science magazine or to kind of preach the conversation to the choir that was really feeling it, but we went outside the box, and I gave an exclusive to Sam Stein, the political director of the Huffington Post, and we asked him to write about the survey that we did. The result of that was our little engine that could, our staff of 2, and the survey that we kind of threw together and that 15 other societies helped with, became a national news story. We had more than 250 media hits in a week. I found it quoted in the New York Times, in the Washington Post, in the LA Times. Members of Congress read directly from the glossy thing that we created on the floor of the House. The highlight of the day was when Barack Obama tweeted one of the stats from our survey out, and that's when we realized we had done something that was pretty neat. And even to this day, just in April, Francis Collins was still quoting from the survey that we had done. So we had done a small thing really well. And the lesson from that I'll tell you all is not to brag, although I will brag because why not? But the reason why what we did was successful was because we did something different and we found a space where nobody was doing anything in. We found virgin ground to dig, and we dug and we struck gold. And so that's my advice to advocates and to people here. This is not an understatement. There are hundreds of people that do exactly what I do down in Washington. And they do it very well, and many of them do it way better than I do. And I'm envious of them and their salaries. But there is always opportunities if you are able to think outside the box, and if you're able to find a space where people aren't talking and get there first. And that's a way that you can really have an impact. And the result, by the way, of those things is my phone rings when there are questions about just the federal budget. I was invited to the White House to talk about how can we get the Zika conversation moving about funding for Zika and move it out of the political discussion. I did an interview, much like Donald Trump, on Russian television. Before it was controversial, I think. Maybe not. But
made it.
That's right. Putin and I are just like this now. But the result of it was I encourage you to be willing to try something different. And if you want to be an advocate, that's where you're going to really make an impact. Don't be afraid to fail. Don't be afraid to be wrong. Our political process shows that you can run for president and be wrong often and repeatedly. But find a space and you can do a little thing and do it really well and make a big impact.
Thank you.
Hi, my name's Kate. As I was introduced, I'm the Senior Policy Advisor for the MIT Washington office. So, kind of in a nutshell, we're the Federal Relations Office for MIT. So we try to keep communication open between both the executive branch and Congress and MIT, and that involves a lot of different things. As a brief background, I'm a scientist by training. I'm a biochemist. After graduate school, during grad school, I got really interested in science policy, science communication issues, got involved in graduate student organizations that were doing those types of things. And that led me to the AAAS Science and Technology Policy Fellowship, which brings scientists to DC to work in the federal government. If you guys want to hear more about that, I'd be happy to tell you about that later. Dan Pomeroy, where are you, Dan? Dan's up there. He's also a former fellow. And could also chat with you. Sorry, Dan, I just volunteered you. Dan's a great guy, so I knew he'd say yes. So because of that, I spent 2 years at the National Science Foundation in the Division of Graduate Education, thinking about national graduate education policies. And then I spent a year in the House Energy and Commerce Committee, learning the congressional side of science policy. After that, since then, I've been at the MIT Washington office, and we do a bunch of different things. I won't go into all of them, but relevant to today's topic is we fight hard for the STEM R&D enterprise, and a lot of that has to do with federal funding. In fact, the vast majority of that has to do with federal funding, especially for basic research. We do this in lots of different ways. We collaborate with scientific societies, other universities, university organizations, et cetera. And we try to find new ways to get the message across about why it's so important to fund science and engineering, and particularly basic research, especially when it comes to the federal government, because no one else is going to fund basic research. So one of the ways we did this is last year we gathered a committee of MIT professors from lots of different professions, asked them to write a story about their field in general, where they think their field is going. So what's the future of what their field can bring, whether this is in energy technologies, plant sciences, health, biomedical research, astronomy, you name it. Anything that can make an impact on society and the economy in the future, but really needs the infusion of federal investment today. And so after we got this committee together, they put together 15 stories that are bite-sized stories. They really give an impression of where America can go in the future if they invest in basic research today. So this is one of the examples that we used to kind of sell the story of why federal support of R&D is critical. We have another volume coming out this fall, and the plan is to, get this out to both the transition team for the next administration, make sure that appropriators on the Hill are seeing this, making sure that anyone that can have an influence on the R&D budget will be hearing these stories and reminded why it's so important to invest. And one of the great things about doing kind of just some sort of event or report or something to get the word out there is that sometimes you can get media coverage. And I think that's one way, as Ben was saying, you can make an impact is once you can get the mainstream media to cover these types of things, then all of a sudden congressmen are quoting it, they're paying attention. So the Wall Street Journal covered this, several other places, LA Times, Reuters, a few places latched onto this and wrote stories. And I think that beyond the actual report itself, probably made the biggest impact. And from then, I'd go up on the Hill, and every once in a while, a congressman would be quoting from this report, and we'd say, okay, yes, someone was listening that can make a difference here. So that's one example of how our office tries to get the word out, advocating for R&D. Another thing we do is we have, I shouldn't say we do it, we help with Congressional Visits Days, which is organized by the Science Policy Initiative, which is a graduate student organization here at MIT that does great work. One of the things that they do that we help them out with is that they go and visit their representatives on the Hill every year. And they tell their story about the research they're doing, why it's going to make a difference, and why it's important for them as emerging researchers to be supported. And I think that's one of the critical things you can do as a scientist is actually just get some face time with your representatives. Show them that science isn't just this thing that's out there that you get an iPhone from after 25 years. It's people. It's making a big difference in lots of different ways, and you can be the face of science and engineering. So I think that's another critical way that everyone can get involved, and I'm happy to talk more about that as well.
Absolutely. All right, thank you guys. Moving along for the moment, if we are graduate students or postdocs, let's say we have a day job, all right, and we're looking for a way that we can advocate in the long run for a strong research enterprise, for that sustained real growth in federal research funding we're all looking for, who is the most important audience for us to reach out to? The federal government, the media, middle schoolers who are trying to figure out their career path in life, our own institutions. So who's the most important audience for us to take our time and our resources and try to reach out to? In whatever order you guys like.
All of them. So I will take a different, I'll give an answer that I don't think anyone here is going to give. I think when we talk about science advocacy, I think we should we should think long term, and we should think the long game. I was talking with someone about that earlier. We're doing good work, everyone up here, and Congress is listening, and that's important. The reason why the Republicans have an overwhelming majority in the House that's kind of overcomable right now is because they invested in the long game, which was they invested in getting Republicans to have majorities in state houses and then invested in Republican governors in time for a census, which would then change the political districting in Congress so that they could run a majority of the states to organize the states in a way to get a majority in the House. That's awesome. I mean, good on them for that. And Democrats kind of got late to the game on that. That's like a 10-year plan. And so that was a long game that they are reaping the benefit of now. So here's my advice, which no one else is going to give, and there's no wrong answer to this. My advice, get friendly with local politicians, people who are active, people who are like state house representatives or the state senate people. I grew up in Connecticut. I'm sorry, Massachusetts people. Every single member of the Connecticut State House today, or the Connecticut congressional delegation, all 5 or 6 members of the House and the 2 senators, are former members of the Connecticut State House. And if we were smart, we would have made relationships with all of them so that when they got to the federal level, they were our friends already, and I didn't need to spend time educating them on the importance of investing in basic research or the research that Yale or UConn does. They'd already know that, and they'd come to Washington, and that would already be in their arsenal. So my advice is find the state people who are much more easily accessible, and get involved with them and offer yourself up as a science advisor, or just ask questions and build a relationship. It may pay benefit in the long term.
Just, I think, to underscore that from Ben, it's not only that they're more accessible, they don't have anybody. They don't have big staffs, they don't have teams of advisors, and so somebody who might be inclined to think about science would say, like, well, yeah, I'm interested, I'd love you to help me think through this. And then, again, you've built that relationship. The point that I would raise, and really underscoring the everybody answer that Ben gave, so the problem that I think scientists have is there's not that many of us. Think about the other issues that get a lot more attention. It's because there's a lot more advocates for lots of other things. If scientists are the only ones calling their representatives and saying, hey, we need more money in the NIH budget, we need to plus up NSF, it's not going to get that much attention. But if it's not just you, but your neighbors, your family, your friends, your other people in your community are also understanding the value of this, and they're making calls, then it starts to actually look like an issue that has a groundswell of support, and it's not just a small special interest group. So I would really, underscore the need to kind of take advantage and create opportunities regardless of where it is. It's great to, try to build relationships and meet with your representatives, but it's also helpful to go and talk to, school groups, not just because the middle school students, but their parents are voters, and some of them may know people, or some of them may be involved with these kinds of things. So, I think one of the most important skills and opportunities is really that communications piece, trying to take what you do to talk about not only the research that you're doing, but why you do it, why it's important to you, why it motivates you. It's easy for people who don't understand to think this is just a whole bunch of eggheads doing things that nobody really cares about. But if you can help make that personal, and you can help, open people's eyes to at least a few examples of why all of us do what we do, then that will resonate, and hopefully, we can engage them as part of the process overall.
I just wanted to ask, what sort of effective strategies have you all found to get scientists involved in advocacy, and what sort of methods of communication do people respond best to in the scientific community? And whoever wants to answer.
Well, I guess they get involved for a few reasons. One is that tends to be their personality, and they're just willing to in the beginning. The second is that we often work with the grad students and postdocs who seem to be more willing to spend some time on this. And I'm a big fan of the power of what grad students and postdocs can do. So I tend to also lean that way. But I think anyone can see the value of, or any scientist can see the value of making sure that they're telling their story. It's just a matter of time and bandwidth, and it's just a matter of how much you can fit into your day. So whether you can convince them that it's a priority that's going to help the entire community as well as themselves, that's where you're going to get more people involved. But I tend to find it easier to convince the emerging researchers to go ahead and take that challenge on.
I would just say that when we've organized our briefings, we've put together panels on timeline of 2 to 4 months turnaround time, which in DC I sense is a long time, but for scientific community and the schedules of high-level scientists, that's a really short amount of time. And people who are booking, 1 to 2 years out, normally we found have been actually very eager to make it a priority to come. And I think some of the reason is that I think they haven't, at least some of the people we've talked to, they've never been asked to come to the Hill. I'm guessing that there are many people who I don't know who working with all of you who are, but it's been a really, I think, interesting experience for them to have that opportunity. So I think that's a piece that these worlds maybe intersect less than I might have expected, and so there is a, I guess, a cool factor, I would say, of having the opportunity to do this and having firsthand experiences. So I found that is very helpful.
I just also want to throw out there that I think it's entirely unfair that we all constantly require you to do the work on behalf of the entire community. It is not, I'm guessing, again, not a scientist, I'm guessing it's not easy to be a postdoc or to be a graduate student or to earn your PhD or your graduate degree. I'm assuming that takes a lot of work. I'm assuming the PI that you work for requires you to be in the lab pipetting or doing whatever scientists do. I imagine it's multicolored things bubbling over in test tubes. That's what labs look like to me. Sexing flies, I think. But it's I will say, and I tell this to my 18-member Public Affairs Committee at ASBMB, that it is unfair that when I ask them, how do we get more people involved, they say we really need to talk to the graduate students and postdocs, as if you were the only people who could be the voices. And so we need to constantly also be reminding your bosses that they need to be active in the process as well and not require you to do the heavy lifting that they will benefit from. You do have to do the heavy lifting because it's your future, and if you're not going to stand up for it, I guarantee you no one else will. It's just the reality. I mean, Adam had said it. Someone else will talk a better game about the money that you could have available to you because they're there talking and you're not. So you have to be involved. But we also should be thanking you for doing the heavy lifting on behalf of a community. And you should also feel, I mean, look, this room is not full. I'm guessing there are lots of scientists around us right now, not in this room. So it takes a very special type of person to be willing to put themselves out and to be an advocate. And so thank you for doing that. And next time, force a friend to be here and make them realize it's not so hard.
I just wanted to add that it's easy. I mean, I was certainly like this. You think, oh, somebody else will take care of that. You looked at the example that Kristen showed earlier, and she said, oh, Massachusetts was number one. Number two was, guess what? Where I know a lot of people. A lot of times those personal connections and things like that really help motivate people to take, sometimes it's 5 minutes out of their time to, send off an email or something like that. We can send, as a community, messages to 100,000 people asking them to call their member of Congress and ask for something, and we pat ourselves on the back when a few thousand do it. And a few, like 2 or 3.
Like 8%. 8% is an exciting number. Yes, 8% did it. 92% ignored us.
And so, and those of us in Washington who ask for these things, we try to be very judicious. We don't ask you to call on every little thing because we understand that you only have so much time. So when you get a message from your professional society, your institution, or a friend saying, hey, this is really important, it is really important. And it's worth your, taking the 5 or 10 minutes to do something because most people won't do that. And what you can do to both participate for yourself and, again, to encourage others to do that, that's the multiplying effect. That's what lets people know that, hey, actually people care about this.
All right, I think next, we've talked about communication quite a bit. We've talked about getting young scientists involved in communicating with policymakers, and we've talked about forming messages ourselves to go present to policymakers. So I want to get a few thoughts from each of you, your thought process on how to convey the right level of technical or scientific detail in a message for policymakers at the state level or in DC.
Well, I mean, I think it all depends on what your goal is. If your goal is to get them to be a champion for science funding, then you need to tell them why it matters to them and their family and their constituents, if your target audience is Congress. In that sense, the technical details are not important. So it really depends on your audience and your goal. So for broad advocacy, the technical details are not something you would usually want to get into.
Yeah, I would say I would never underestimate the power of stories. I think that's what Kate said is that stories then backed up with a few quick, hard facts, not super technical. But I said I have this feeling. I will say this as I have not spent a ton of time in DC. Sometimes asked really quick questions about talking about precision medicine and, well, name 5 diseases where that's relevant. Boom, 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 boom. It's a different way of communication, so I think it's worth, spending time with folks like this who are really expert in the kinds of communication that resonates really well.
Yeah, I would say it's a tough thing, and scientists often have trouble, getting rid of all the detail and all the nuance. If you're going and talking to somebody, probably at almost any level, they're not a scientist. They're often people who last took a science course, their freshman year of college. They don't know a lot of this stuff. Scientists often like to go and kind of go into all the detail because that's what excites them. That's why they became that. But it's hard to translate that into something that resonates with somebody else. I remember when I first came to Washington on the first congressional hearing that I was watching, I don't even remember the topic, but I remember that the people, the elected officials on the panel were just amazed that they had a table with PhDs sitting at it and thought, oh my gosh, you all are so smart. Look at all these PhDs we have there. In the scientific community, that's kind of a given. And that's what they were focused on. They weren't focused on what the topic was or what people were saying. They were just sort of in awe of these people. That's actually a good thing because we can take advantage of that. We have authority, we have respect, but we need to talk at a level that, as Marnie said, relate to something that they know about, that they care about. Not all the latest results, but really the big picture perspective. I do this because I'm trying to find a cure for cancer. That doesn't mean that you're going to find the cure for cancer, but maybe that's what motivates you, and then you get into how your little thing might fit that. As little jargon, as little expectations of understanding, sort of the more effective that you're going to be in reaching somebody.
And try to, when you say I'm studying a cure for cancer, take out the cancer is not actually a monolithic thing, but there's actually a variety of things. And really the breakthrough that I'm going to have may impact 1% of a slight. Don't just you're trying to find a cure for cancer. There's a White House staffer that I've worked with who she has a saying that I like a lot, which is. Data makes you credible and stories make you memorable. And so that's, I think, really good advice. It depends on the member of Congress you're talking to. Our keynote speaker, Rush Holt, if you met with him while he was in the, I broke the table. If you met with him while he was in the House, he would gladly listen to the reams of data that you have. There are other members of Congress. Ralph Hall is one that comes to mind. He's not there anymore, but he would probably not want to listen to your reams, but would love you to spin him a good yarn, and that's what would get him along there. So I think that goes a long way. And remember 3 easily digestible but impactful facts so that you can just kind of spit them out. Did a lot of people here watch The West Wing? Did anybody watch that? When I first, so I came to Washington partially because of that show. I loved that show. And the first meeting that I was in, people rambled off facts like they do in that show, like Josh Lyman would while he's debating with Sam Seaborn. And I sat there and I said, holy crap, this really happened. But the reality is when you go to a meeting and you have those 3 facts, the next meeting you go to, you can use those exact same 3 facts and they're going to be just as sterling, shiny, and new for the audience that you're talking to. So just being able to be conversant over your small piece and being passionate about it really does go a long, long way.
And if I could add one more thing, my biggest advice for science communication is just you have to practice a lot. It's not easy. Some people can do it very easily, but most of us have to practice a lot. So just put in the time. Sad but true.
It is.
Yeah, so on that vein, we want to have an idea of if any of you could come up with an example of when science has failed to get the attention of the general public, and maybe a specific thing that science is failing to communicate about that they might be able to do better.
Well, there's a lot of classic cases, so climate change, vaccines, Zika, GMOs.
So where do you think that those messages are going wrong?
Well, so, yeah, I'll say a very small thing, and then Marnie can probably speak about this in much more depth, but I think part of the issue with these big science and society issues is that scientists forget to bring the public in from the very, very beginning. That's especially true for GMOs. GMOs got to be really scary, and that's, I think, in part because the scientific community didn't communicate well from the super early stages. And now it's not too late. I'm not saying it's too late, but there's a lot of catch up to do with GMOs.
Yeah, I agree. So I think with GMOs, there's, actually, let me take a second, that engaging the public early and having the conversation in a different space than we're used to, the value space. There's a lot of hard science that is going to come to bear on these conversations and play a really important role. But that might not be the beginning of the conversations is what people care about. And that's where a lot of people are starting. And so framing it in that space then makes people want to hear the facts. I think a second point I want to make is that I've heard, from, more than one person, why do you scientists think you know so much better than the rest of us? I think there is a sense, and on some really issues that have gotten very contentious, that the diversity of people's viewpoints is not respected. And I think that comes through loud and clear. And so I think that's why pgEd takes probably somewhat within this room a controversial stand about how we talk about things, like when asked about evolution. I think anything that we say that excludes people from the conversation puts up a wall. And so I think it's really important to make people feel like they have a valid opinion, however, they arrived at it to have a productive conversation where you can share information, but where somebody who may be coming at it from 180-degree, the opposite perspective, at the beginning, where you guys can really talk. And then that gives an opportunity for people to change their mind. I think when people feel like they're heard, it really changes the dynamic.
Yeah, just to say, I think the importance of having a conversation and not a lecture. We as scientists tend to do ourselves a disservice by coming in and just saying, well, these are the facts, that's just the way it is, and not necessarily hear what other people are saying and what their perspective is, and engaging them at a place that they are. We try to have the conversation where we are, but that's the point. It gets coupled with kind of the general sort of challenges of science education, which is the sense that most people don't know what science is, what science does, what the kinds of things that people can answer. And, any of these issues that people, mentioned, with vaccines or climate change or whatever, they just think it's a debate just like any other debate, and don't understand, no, there's certain kinds of processes and things which are unbiased, that we're trying to get to the bottom of these things. But most people don't understand that, and when you talk loudly and they say, well, somebody else talks just as loudly on the other side, how am I supposed to know? And if there was really a conversation about these things, then, hopefully you start to educate people not just about the particular topic, but the way that you approach this, why you do it, what evidence actually means, and these kinds of things, instead of just trying to say, that's just the way it is.
Also remove from your vernacular things like, you may not understand the importance of. That's a quick way to turn off. I get scientists telling me that, which is fun. But again, it goes back to just being able to have you said it really well, which is to have a conversation, not a lecture. Nobody likes being told that they don't know something or that they're not as smart, and so avoid doing that, but still get your point across. Takes practice.
Yeah, I agree with this point about it's a two-way street. We have a lot to say, but a lot to learn. And I was just reminded of a conference we held which brought together people from communities of faith, educators, leaders of genetics and genomics industries. And we had a high school teacher who has worked with us for a while who came, and he decided to take out an activity from one of our lesson plans and try it out on this group, which hadn't thought of doing. Great idea, I loved it. And the activity is that people move to the corner of the room based on how much they agree or disagree with a statement, and a statement that's meant to be intentionally vague, broad, open to interpretation, so that there is a good distribution of people around the room. And what was fascinating to me in this particular context was to see that the scientists and the non-scientists in the room were well mixed for many of the statements, and they were all distributed across their groups and between groups. And so I think that that's important, that we often as scientists are not talking about the issues from, the perspective of our personal beliefs about how we do or do not choose to use a technology, and that actually there's probably more diversity within our community than we realize in terms of the opinions about that. So.
Thank you.
All right, we want to make sure everybody's aware we've got a couple of microphones up on each of the aisles. We'd love to get some questions from the audience going. So if you've got a thought on your mind, something you'd like to ask the panel, go ahead and come on up to one of the two microphones on each side of the room. We'd love to open the discussion up. We'd love to hear what you guys are thinking. While you guys find your way to the microphone, I'm going to ask the panel, what do you think the biggest barrier, and any kind of barrier, political circumstances, not enough advocacy, particular people, what is the biggest barrier to that sustained real growth in science funding that we're looking for?
I'm going to say politics. There is more support. So life sciences is where I live. So NIH and NSF, largely NIH. So that may be different for some of you depending on where you are. There is more support on both sides of the aisle to support the NIH and to increases the NIH budget than anybody would give, I think, to be fair, anybody would give Republicans a fair respect for their opinion on that. However, politics messes everything up. So there are Tea Party, ultra-conservative Republicans who would call and support doubling the NIH's budget. Unfortunately, in order to do that, they would defund Planned Parenthood, and Sesame Street would be out of a job, and all of these sorts of things, that priorities would get in the way. And so the political priorities, I think, is the barrier to it.
I would also say that very much coupled in with that is the sort of the short time horizon of elected officials. They have to worry about getting reelected. And so, they want to cut taxes this year, and what happens 10 years from now is somebody else's problem, or hopefully it's their problem, but they can't deal with it now. And so the kinds of things that we in the community talk about, we need this sustained, reliable, consistent, with a trajectory and things like that. Those things don't jive well with how the system actually works. And so people are after the sort of the quick win rather than the thing that most people would agree is in our long-term best interests.
We also, by the way, haven't defined what sustained investments actually really are, or what the goal of that is, which is a problem.
I don't have too much to add, but I think sadly that science and engineering everyone's for it on both sides of the aisle. It's just not their number one priority usually. So in a world where there's a lot of priorities and constituents call you for very specific things that are affecting their lives this very moment, it's hard to rise to the level of keeping it as the number one, despite the fact that it's a huge driver of economic growth and all kinds of wonderful things for your society. It's hard to keep that long-term vision in mind.
Okay, looks like we have quite a line, so let's hear from the questions from the audience.
Timothy Castis, postdoc at MIT. So the majority of scientific research happens in the context of training PhDs and postdocs. And I think we all agree there are way too many PhDs and postdocs. So where should the money we're asking for actually go?
So maybe first, let's actually do yes or no down the panel. Are there too many postdocs?
That's complicated. How do you like that answer, yes or no? I think about this issue a lot. I think that there needs to be better opportunities for PhDs and postdocs. Doesn't mean we need to just kind of cut everyone out of the equation right away. It'd be better if there was more kind of sustained opportunities for emerging researchers, but I think that there are other ways to find meaningful careers with a background in science. So I wouldn't necessarily say there's too many, although it'd be nicer if there were more opportunities in academia if that's what you wanted to do. So in that sense, there's too many, yeah.
That's such a scientist answer.
Thank you, sorry.
That was so great.
Caveat,
There are too
caveat,
many, so
caveat.
this half, you all need to do something else with your life. I'm very sorry. This half, you're good. I'm going to take the stance of there are not too many, because I believe that America's a pretty great place, and I don't think there's such thing as having too many really bright, talented people. We need to do a better job to find you opportunities. Actually, I'm going to rephrase that. We, being advocates, but you all too, okay? No one promised me a job. I found my job and I found my career, and it maybe wasn't the path that my mom or dad would have wanted, but if we all work together, we should be able to find the opportunities that you need.
Yeah, I mean, I think, part of this is really that opportunities and being okay with that as a whole, as a society, as an enterprise. I mean, sorry, Ben, 3 of us up here with PhDs and we're not doing research. Some people would say that we're failures. It was a waste of, government resources that help pay for our education and all that. I think no. I think we need a lot of that training to do it, but we need a system that says it's not only okay, it's great to have these people out there. It would be nice to have more than, a handful of scientists in Congress, for example. It would be great to have more people with scientific training and experiences doing all these other things. And it's not that they're not, we have this question sometimes at work, who's a scientist? And I was like, I still think I'm a scientist. And I'm trying to use some of that training, maybe not the details of my experiments, but those kinds of things. And so, trying to sort of broaden the definition of success and stuff helps make it okay for these things and helps give people a little bit more sense that, this is a good thing. And when we support some of those other science-aligned things that are outside of research, that's good.
Yeah, ditto. I think that an event like this would not have happened when I went to grad school, and I graduated a decade ago with my PhD. I think that this is a great sign of helping to bridge those, that gap between the end of your graduate career, the end of your postdoc, and like what's next. That was not fun, but I'm so happy where I am now. And so I think helping to have more support for that is really important. And I don't know a lot about this, but I was at a conference, the Science Education Partnership Award, and there was somebody from NIGMS who was talking about how, research has gone on a trajectory like this, or I guess like this for all of you, and that graduate and postdoc education stayed like this, or graduate education, I think he said. And that's something that, it's time to change. And I think the NIH is working on that. Maybe some of you are involved in that. But I think that, hopefully we'll be part of that process.
To get to the root of your question, though, I think we need to find ways that if you don't want to have an academic career, to help you get out sooner, to give more exit ramps. You're nodding your head, so I feel good about this. More exit ramps so that you can get out sooner. Maybe you don't need to have the PhD that you thought you needed to do the career that you want, but you need to know that that's an opportunity to, or you have a PhD and you want to. We need to help open up those opportunities. At ASBMB, we're looking at that. We're talking about the role the staff scientists can play in a laboratory. Maybe, you don't want to be an academic, but you do want to work in a lab, but you can't be a postdoc forever. So what if labs utilized staff scientists more often in their lab? It would decrease the number of postdocs because a staff scientist costs more, but it would open some opportunities and kind of force some changes. That doesn't mean that there are too many, but we need to get people going in their career path earlier on so we don't end up with a glut at the very end, I think is a fair way. I think that's answering the question you were asking.
Thank you.
Just to underscore Ben's thought, the system that we have, and I also come from the life sciences, was never really designed. It just kind of happened. And so we have these R01 grants and postdocs and grad students that get funded there and not through any purposeful way. It just kind of happened. And so we're sort of stuck with this, or we've acted like we're just sort of stuck with this system and things like that. I mean, I know a lot of people personally who's like, I love doing research. I don't want to be a PI. I don't want to manage a lab full of people and have to worry about this stuff. But there aren't other opportunities. Having, I mentioned that I worked on this Bridges to Independence report. So the K99 thing, when happened, we also had a lot of discussion about staff scientists. Nobody did anything about that standpoint of trying to make a viable, well-respected, stable career for people who just like doing research that can have independence and stability, but they don't have to play the rat race and try to keep competing for this declining number of tenure track jobs.
Hi, I'm Zach. I'm a PhD student at Brandeis University, and I was wondering if you wanted to offer some thoughts on the influence / use of / fighting against the echo chamber that is the internet these days. And particularly, I got thinking about that when you were talking about these sort of hot button issues just a moment ago with regards to climate change or where it's beautiful in the sense that you can go and you can look up the entire breadth of research that exists on the subject, but there's also so much misinformation out there. And for myself as a trained scientist, I can very easily parse through that and know what's true and what's junk, but the average person out there doesn't know how to do that. And so you'll frequently see people like citing blatantly false information as fact and using that as arguments against or for various issues. And so I was wondering if you guys had thoughts on how to use or combat the internet in that sense.
Don't get in debates on the internet.
Too late.
Don't turn off Facebook, man. Between now and November, now's not the time.
It's hard. I understand it. And what makes it even harder is some of the research on science communication actually says that if you present people with more facts, that they actually turn harder against you. Great. So what are you going to do? It's tough. So I don't have an answer for you, but this is a guess, is that try to think more about the values that they're coming with and try to appeal to those values, like the safety of their family. If they live on the coast, what's that going to be in 20 years? I don't know. And I should not be giving this answer because I'm not an expert here, but I'm just guessing you got to come at it a different way than just saying, no, look at the hockey stick. Like, we're getting warmer. Facts don't seem to work, and that's what the research shows. Very sad, but it seems to be true.
I think we'd like people to, think that the reputable organizations, have something more to offer, whether it's ASBMB or MIT or whatever, that if they say what it is, it must be important. But as you point out, that's not really how the internet works. Anybody can put out a shingle and claim to know something about something. They often disguise it even with some legitimate sounding, entity and series of degrees. It's tough to do that. To the extent that we can have our search results show up higher when somebody Googles, and so at least that they're finding this information, maybe that's good, making sure Wikipedia is accurate, and if not, changing it, just trying to do as much as we can. But I think I wouldn't say it's a losing battle, but it's challenging because there's a lot of other people out there, spouting drivel.
I mean, I think I would come back to what Ben said before. I liked what you said, the long game. It is not trivial to scale trust. I think it's very achievable and within a short time frame if resources are dedicated towards that. The resources are limited. And I think that changing somebody's mind on the internet, I guess it's part of, what are we putting out there, trying to make sure that our first response, whatever pops into our head, maybe we sit with that for a little bit before we tweet about it, and find a way to frame it. There was an episode of the X-Files, the new X-Files, didn't see it. But I know that it was about CRISPR. I heard that it caught a lot of flack from the scientific community about the way that CRISPR was portrayed. I can imagine how that happened. But also, I heard that, people were really interested in this storyline, loved it. So you could imagine a lot of tweets going out. I feel sometimes too old. But going out and maybe just going right over each other or past each other. I don't have the simple answer about how to make it better, but I thought one scientist who I thought did something really nice is say, it's great to see CRISPR on the new X-Files. Here's 10 facts that I think are really important for everybody to know about CRISPR. And so maybe it's just a little shift towards not railing against, but saying yes and taking opportunities. It's not a fast process. A lot can happen one-on-one. If everybody in this room goes out there and is really taking that sort of approach to heart, I think a lot can be done.
Just want to add one thing. I always think that we're in a way fighting with one hand tied behind our backs because we try to say things that are true and based on evidence.
Yep.
And that makes it hard because it's just, you just can't, purely as a rhetorical matter, it's hard to be as convincing and eloquent when you actually have to ground yourself in what's actually true.
You just preempted my follow-up question there, Adam. It was going to be, which one is harder, posting something intuitive sounding but wrong on the internet or debunking it? So there we go.
Thanks.
Go over here.
Hi, I'm Darren. I'm a grad student in the biology department here at MIT. So I feel like when I read, every week I get, journal digests, and there's really interesting commentaries from people all across the life sciences that say, we should fund science in this way, or here's why grad students should go out and advocate for science. But something that I don't often see, which I feel like could be a good argument, and my question is basically, do you use this as an argument? But how often do you bring the economics of funding basic research to senators or congressmen and say, hey, the long game, we invest now, you see a return. You invest in the Human Genome Project, you see 100x return because you've created all these industries. Same goes for basically every technology you've ever created in this country, so yeah.
We use that argument all the time. And this report was trying to say, hey, it's going to keep happening, but only if we keep investing. But the thing that is tough is that not every investment pays off, right? Mm-hmm. You have to invest in 1,000 things to get 10 that turn into an economic driver. And the investment is worth it, and you have to be broad, but it's also hard to point out, okay, this investment you're making now, that's going to be the next Google. So that's why it's hard to say keep investing, because in the future it's going to work out.
So it's kind of like a risk. It's a risk thing.
Yeah, I mean,
Yeah.
But we still use the argument all the time. It's one of the biggest drivers of economic growth.
Sure.
Yeah.
Yeah, it's one of those arguments that, again, it's dependent on the office. Some of them will pick it up. Absolutely. I mean, whenever we go to a meeting, we bring with us data about the number of jobs, the number of dollars that are flying into either that state or that district, the amount of patents that have come out of that state or that district. However, it's tough when you talk to, in the middle of that meeting, that member or that member's staff says it's okay if I cut the NIH's budget because the universities will fill in that gap in funding. And they don't recognize that the money the universities are using is the NIH's money. So that's just difficult. It's difficult when people will tell you you shouldn't invest basic research because we're America and we do better than basic things. We do advanced things. But that is a legitimate data point from a legitimate scientific poll that I saw why there were people that deprioritized basic research. So we still have to battle those things before we're going to be able to make a significant impact on the economic advancement argument.
Just, I think, to add that we worry a lot about, there's a lot of rhetoric, you hear it from one presidential, how are we going to fund this? Cut out the waste. So in a way, people say, well, the waste is all these investments in basic research that didn't pan out.
Shrimp on a treadmill.
And, you know, the problem is, and it's hard to get people to understand, well, we don't really know which of those are, because it's easy to say, well, we want to fund only the ones that are going to pay off and not the ones that aren't. But that's not how basic research works. You know, every year there's all these lists. The Waste Book is one of these wasteful government spending, and you look at it and they, you know, they could find, you know, maybe 100 NSF grants that are wasteful. And I look at that and I say, that actually sounds pretty good. You could only find 100 because they're funding however many thousands. That's a pretty good batting average, but they make the opposite argument. And so, you know, it's hard to, it's again, the process and understanding kind of how this works. People don't understand it's easy to get sound bites and talking points of, hey, we wasted all this money without appreciating that all the other things that you thought was a waste are actually really good.
Yeah, the reality is those sound points are better and easier to get out, right? Government is wasting money, therefore we should cut government, is a lot better than the investment that you make in today may work in a cancer treatment down the road 15 years from now, but it may not. Maybe it'll help something else, and at this point, nobody's listening anymore. So it just...
And there are efforts. The Golden Goose Award is something that's been around for a few years. I think is being awarded just another week or two, which was trying to sort of do that. These are things that sounded silly on the surface, but really have paid off. It's great to do that retrospectively. The thing we can't do is prospectively and say, this thing grant right now is going to do that 10 years from now.
Thanks.
Okay, guess it's my turn. Hi, my name is Dina Solomon, and I'm a neuroscience master's student at Brandeis. And my question for you guys collectively is, what kinds of things do you think that graduate students, you know, on campus and in the community can do to not only educate themselves about how all of this advocacy works, but also how they can contribute to the student body on their campus? I just real brief, my background, I came from Florida, so I've never been up here before. This is my first time here at MIT. And I came from University of South Florida in Tampa, much bigger campus than Brandeis. So for me to be involved over there and, you know, 50,000 students was a lot more difficult than, you know, here, because it's hard to get your voice heard in such a big crowd. So what do you guys think?
So you're asking how to get heard on campus or in
Well, yeah, just
the bigger
in
world?
general, like what kinds of things can students do to be active?
Yeah, I think banding together whenever possible is good, and sometimes it starts out as simple as having a discussion group about a science policy that's of interest to you, or having like a pizza night where you bring in a speaker who talks about energy policy or, you know, neuroscience funding or whatever. You can find, I guarantee that on every campus, maybe I shouldn't say that, on the vast majority of campuses across the country, you'll be able to find a faculty member who has had some experience in policy, whether they were a rotator at the National Science Foundation or whatever, pick their brains, kind of get a sense. And that, I mean, that's just a good initial way to start, but just an idea. I think there's a lot of things you could do.
I'd be fired if I didn't suggest getting involved in professional societies, which have active, some of them have active student chapters or chapters at universities, depending on the organization, but certainly have kind of national advocacy and are looking for and have opportunities for you to participate.
I would underscore that the staff of most professional societies is a lot smaller than you would think. And one thing that we all want are people who are going to do things, that are volunteers, that are eager, that are motivated to do these kinds of things. And so just checking in with, you know, whether it's SFN or somebody else and saying, you know, is there some way that I could help? Could I write something? Could I be on a committee? Could I volunteer to, you know, organize a meeting? You know, they won't always, you know, have the same priorities, but you know, finding people that want to get involved, it's great.
Yeah, and pgEd also, I mean, we're a little bit different, but I think that there are opportunities to get involved in education and public communication. I mean, I can think of a few efforts, I mean, where grad students have banded together and have an organization at Harvard, I don't know if it's the medical school or the whole university, Science in the News, and so there are efforts to, you know, join something like that. We've had graduate students, postdocs, you know, work with us, write with us, present in professional development. So I think that those opportunities are out there. There are certainly a lot of people involved in science education. where those opportunities can exist, and sometimes have on campus, focus groups where once you've heard about it, I mean, you can start to network within that community, since it's a little bit peripheral to some of the more standard science forums that we're used to.
And also go to National Association of, the graduate, NAGPS, the National Association of
Graduate and Professional Students.
Yes.
National Association of Graduate Professional Students is what that was. MIT's a member. I actually don't remember right now if Brandeis is, but if you're not, you should be. They have legislative action days each semester, fall and spring. All members are invited. It's a big group gathering. It's an opportunity to learn a lot, actually, about what other universities are doing. Easy way to get started.
There's also a grassroots group called the National Science Policy Group.
Yep.
And anyone can start a chapter on their own campus, and they provide you with resources. Just Google them, you'll be able to find them. They have lots of activities as well.
So if you don't already have a science discussion group getting together periodically to figure out how safe are GMOs anyway, or something fun like that, you might very well be the one to start it.
And one thing that I should have mentioned, because my boss is going to be here soon. So AAAS also has some opportunities. There's a catalyzing advocacy in science and engineering, which is a fairly extensive training period. But the AAAS annual meeting is in Boston in February, and there's a half-day workshop as part of that, which is free to AAAS members, about how to get involved with advocacy. And it's not only a good way to learn about things, but to meet the other people who are there. And my guess is there may be some others from Brandeis who will be there.
All right, great. Thank you so much.
Hello, my name is Ben. I'm a postdoc in climate science here at MIT, and I've done a fair amount of communication in festivals and museums and with families and kids in a climate science capacity, but often they interpret that as a broad science capacity, so I get questions about climate science and kind of the rest of science. And you have any advice about good ways to say, I'm not an expert in that, but I have an opinion about it, or I have a thought about it, or kind of where the line should be drawn in that kind of dynamic?
Yeah, I mean, that's great. Well, it's great to hear that you're doing all of that stuff, and I just can't even begin to tell you about all of the things I go into a classroom to talk about, and the breadth of questions students ask and fire at you. Saying I don't know is actually a part of it. I think it's good. I think, depending on the situation, I don't know and I'll get back to you. Also a good one. And then I think when you do have a perspective to offer, you can kind of say, I like what you said. It's stepping back and saying, this is not exactly my area of expertise, but here's the things that I can say about that. When you're not sure, always good to say, I think this is true, but I'm not sure. I mean, it's just doing your best to, communicate as transparently as possible. Yeah, there is an assumption. We know, that we know everything within broader fields, and that's part of making people aware of what it's like to be a scientist.
And some of us act like we do know everything about everything, and our credibility is important. So being able to say, this is what I know and this is why I know it, and this I don't know, you could say, I'm going to speculate, but I'm really not an expert in this, or to the extent possible, try to walk through how you would approach that question, and hopefully challenge whoever's asking that to go and find it out, but you can help point them maybe to some reputable sources for that.
Yeah, I'd second, go ahead.
No.
I'd second what Adam said, is that you do know the scientific process, and if it's a kid, then it might be an opportunity to say, well, how could we design an experiment to answer the question you are looking for?
I work closely with a social worker who has stuck it in my head and it's something I apply to my own kids, is thinking about where that question is coming from. Sometimes the question they're asking is actually not the one that you hear. That still, is a challenge for me. I'm working on it a lot, but I think that there's something there.
Thank you.
Hi, I'm Jacob Colbert. I'm a PhD student in physics here. And I was just struck in the opening presentation about how there are 3 high-level executive staff that were citing these issues and the student report. So I was just wondering what sort of subjects would be better to approach in the executive branch. And since they're not directly responsible to us in the same way that the legislative is, how do you go about advocacy with the executive branch?
It's different. because you're really speaking in those instances more with people who really do know the detail and the minutia. I would not, in working with the NIH or the NSF, and when we have a policy issue, you have to know your stuff because they know their stuff as well. And so that is the example where you do bring your reams of data and you do make a really thought and analyzed and provable argument. But I don't think you should avoid it because those people are in many ways glorified customer service people, right? I mean, if you're working at the NIH, you are working, to help with the facilitation of the work, the important work that the NIH does. So it is different, but a lot of these people do have, the NIH institutes have public, their council meets publicly. They have open session for the public to make comments. So you have the ability. They are all the time. All of the NIH and I'm sure the NSF and the other agencies have, requests for, open RFIs and RFAs looking for information, looking for public opinion. Those are really great opportunities for you to get your voice heard, and I would encourage you to find those and to make sure that you take those opportunities.
And relatively few people take advantage of some of them, particularly some of the advisory committee meetings. Now, if you're in Boston, it's sometimes a little impractical, but they're often webcast. I know if I go to an advisory committee meeting at, say, the National Science Foundation, they're bio-directed, everything that they fund in biology. Who will be there? The members of the council, the staff, and like 3 people from outside. And so if you have the opportunity to participate either in person or virtually, you're often one of the few, which means that your input gets considered more because you have the opportunity to speak because there's not a long line of people.
So I actually want to jump in and answer this one because I just had a meeting with an executive agency about 3 days ago in DC that was of the form, thank you very much for writing this new regulation extending the length of time Class F visa students can stay in the US and work. What are you planning on working on next for students? And they were blown away by that. Immigration and Customs Enforcement apparently never hears anyone come in and say, thank you for writing that new regulation. It just doesn't happen. So, something you can try sometime if you like.
All right, thanks.
Hey, Mohammed Farazmand. I'm a postdoc in mechanical engineering. The House of Representatives Minority Leader Nancy Pelosi claimed that the iPhone was invented by the government. And actually, I think there is some truth to it. What she meant was that every technology that went into iPhone was supported by the government grants and then put together at the end. Now, you would have thought that because of this, and the question on the other aisle brought it up, that the economy is driven by technology, and I hope everybody agrees, by science and technology, everybody agrees in this room. You would have thought that they, in the Congress, will have a meeting like this, finding a way to make scientists like our representative in the Congress more than instead of us cutting out a few hours of our day, not doing research coming. So my question, I guess, is along the same lines as the previous question. Where did we go wrong? What happened? How can we persuade the taxpayers that actually what we do here is important? And yes, most of it will not lead into a breakthrough that drives the economy, but that's the way it is. How can we persuade the taxpayers to actually push their representatives to back us and listen to us?
I mean, I agree. I mean, I think that's partly why I was suggesting any opportunity you have to talk about what you do and why you do it, it's important. Go from the data or the breakthrough to the story, to the personal. The more that, you can help anybody else understand what it is that you do and why, over time, helps make a public that's more informed about science and engineering.
DC is a city where the first question people ask is, what do you do? I don't know if they do that in Boston, but they do it in DC. A good way to answer the question as a scientist, you can say, I work for you. And then the person looks at you and says, what do you mean? Oh, well, actually, your tax dollars pay for me to do the research in my lab, and I'm working on helping to find a cure for cancer, period, end of sentence. Which happens a lot in mechanical engineering. Yeah, sorry. But I mean, that, any opportunity you have to do that. As to the where did you go wrong, people didn't, here's something to remember, the people that are elected to Congress were elected by the majority of, in that district. So they don't think they did wrong. Interesting fact about Congress, everybody hates Congress, but everybody loves their representative, right? That's why the incumbency rate is like 85 to 90%. So think long game again, and think about the more people that you say, I work for you, and then they understand what you do, 5 years from now, maybe it'll start to become more accepted fact and part of the discussion.
So life sciences has it easiest because you can often, not always, but often draw a connection to health and how that's going to make you and your family healthier in the future. And the reason why that works is because it appeals to something that people care about. So you got to keep telling the stories about why engineering and other physical sciences, why these other things end up mattering in people's lives. And it's not as easy outside of life sciences, I know, but that's the nugget that works for life sciences. You just got to find the angle for the non-life sciences and engineering as well.
And just to add to a place to practice those skills aside from anybody that you come into contact with is that Sonia Hall over here. I should have mentioned it earlier. She runs a fantastic DNA Day program that's just launching here in Massachusetts. She worked on that as a graduate student, launching a program in Kansas. There's parallel efforts going on nationally and internationally, and it's a day to go into a classroom with a curriculum that finite lesson plan, so they give you something so that you know what to talk about and how to do it, and it's an opportunity for students to interact and learn about what it's like to be a scientist. So that's a great way to do it with a reasonable allocation of time and what you can afford to do given your other priorities.
Thank you very much.
Hi, thank you all for being here. My name is Jeff Moran. I'm a postdoc in nuclear engineering. So we're all here, the title of this event is Advocating for Science, right? And that's a very broad phrase, right? And I'm just wondering if we should be thinking a little more specifically. There are probably, different people in this room will have different answers to what it means to advocate for science. And so maybe in the spirit of maybe inspiring some people in the audience to formulate their own personal mission statements for advocating for science, because one person can only do so much, right? I'm interested in what motivates each one of you. And if there's something maybe in 10 years, if you could wave a magic wand and would have, that you could have happen, what would it be?
I work in the life sciences, which makes it easy. I, up until 10 years ago, never had a family member deal with cancer before. I was very, very lucky. And then I watched my 3-month-old nephew take 6 months to die from leukemia. And it made it very easy for me to go to work every day and say, I don't want to see another family deal with that ever again. And the people that I work for may not, cancer is not a monolithic thing and blah, 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 blah. But it's easy for me to wake up and say we are doing the right thing by funding NIH investigators and funding NSF investigators and funding mechanical engineers, whatever the hell mechanical engineers do. It's easy for me to know that we're doing nuclear engineering. I'm sure that, anyway, it's easy for me to wake up and be motivated by that. And so that's what motivates me to work hard every day.
I mean, I think that's really important that, the human dimensions of what we're doing. I mean, I know that's part of how I got to be where I am at pgEd was my own personal experience with genetic testing when I was, 10, 12 weeks pregnant, Ashkenazi descent, and, nothing that intellectually should have surprised me, to know that they wanted to do extensive carrier testing, but when they took 17 vials of blood, I was stunned, right? I mean, yeah, it's shocking, and so I think being able to comprehensively, and I'm going to be really bold and say within 5 years, comprehensive awareness across our nation and efforts spreading out into the world that these technologies exist, conversation about the benefits and the implications, and that people have the confidence to ask questions and to make informed decisions, and just to know that this is out there. I think, there are fantastic efforts working with the healthcare professional community, but that is not the only way that takes time too.
Sorry, by this you mean GMOs?
Sorry, personal genetics, I mean, GMOs is not an area that we've really gotten into, but I think with thinking about CRISPR, I think that's certainly a topic that we're asked about a lot, but how learning about one's own personal genetic makeup can inform healthcare, both treatments, predictive, and also thinking about technologies for modifying, our own genomes. And so I think that's right up there against GMOs.
I mean, I would say that in addition, I think a lot of people are motivated by personal experience. It's one of the things that helps some of the people in Congress who do support science. It's often because of something like that. They finally have the motivation to look into what's going on and why isn't this working or why is this working. I think beyond that, science, is a lot about sort of curiosity and kind of finding things, which in some sense seems a little frivolous. Why are we doing this? But it's really about trying to understand kind of our world and who we are. And thinking back on my experience, I kind of got tired of the drudgery of being at the bench and trying to do that. But I still cared passionately about the subject. And so I was thinking about how can I contribute to really fostering those who are motivated to get up in the morning and, spend 14 hours, sitting there pipetting or whatever it is that people do, right? And, both in policy and particularly in the professional society world, it's a way that I feel like I'm contributing to help others be more successful, be able to help find their path with sort of less angst and less sort of soul searching, really helps motivate me to think that, my efforts are hopefully helping a large number of people who are experiencing a lot of the things that I went through and trying to make it easier for them to follow their passions and, oh, by the way, contributing to society as well.
So I was originally motivated by climate change and the huge disconnect between what decision makers were doing and what scientists were saying. And then the more and more I thought about that, I thought, wow, it's not just climate change. There are so many issues in which the evidence is not being used by the decision makers. And so and now I'm very much a generalist. In fact, I was never a climate scientist. It was just a personal interest. But just that general disconnect between taking evidence and using it for decisions is now the thing I'm most interested in a very general way, and it applies in lots of different ways, and that's why I'm pursuing science policy.
So in 10 years,
yeah.
every congressperson making everything based on evidence.
Yeah. 10
Like
years?
Neil deGrasse Tyson
That would be fabulous.
I was afraid you were going to say all members of Congress would be scientists, and I thought that seems scary as well.
We don't want that either. We don't want that either.
Yeah. All right, thank you all very much.
Hi, my name is Elisa, and I'm from the Netherlands. I was actually inspired by some online poll we had in the Netherlands last year, and it was really popular. People actually had to give their opinion about what the most important topic or dilemma in society was, according to them. And based on that top 10 societal problems, science was inspired, or researchers adapted their research topics based on the current societal problems according to actually evidence of the Netherlands. And I was wondering what your opinion is on science adapting to what actually are the popular issues. So not really about changing policymaking from this perspective, but more maybe even changing science and adapt it to popularity. I'm not saying that I'm advocating for that, but I would like to know what you think about that, or what your
Didn't the
opinion is
NSF
on that.
Didn't the NSF do a study on the report, the grand challenges of the next generation? Is anyone here able to speak intelligently about that? I don't know. It's safe to say.
No, I mean, I think there have been a number of sort of grand challenge efforts which sort of try to get at that. challenge, is that it's often the experts coming up with the challenges rather than a societal thing. You know, there's always a challenge that the public doesn't necessarily, know
Yeah.
what the best thing are. So, you might have kind of like the poll for Bodie McBoatface, and then the UK said, actually, we're not going to pick that after all because we left it too open-ended. But I think the idea of engaging the public in thinking about these issues makes a lot of sense. It's a lot easier to tie back if you're trying to explain why you do what you do, and in some level, it ties back to something that was identified by the public. That kind of thing is helpful. It's just, needing to be broad enough that it can incorporate, the things that experts actually do know are the best ways to invest.
There are places there are people and groups that are trying to democratize science and science funding in a way. There are some science crowdsourcing opportunities that exist where you can put up, on a website, a Kickstarter sort of what's, I think the GoFundMe or the SciFundMe Challenge or SciFund Challenge is one that comes to the top of my head that exists. But where scientists can post and say, I'd like to do research in this, and people can donate their own dollars. And so that is one way to maybe get in the direction that poll reached, that people are taking advantage of and may have a bright future into the future.
Now, one of the challenges of finding solutions to grand challenges is where do you send that grant proposal? So I think there are a lot of scientists that are motivated by grand challenges, but grand challenges are usually solved by an interdisciplinary approach. You can't just send it, you can't just get funding from one particular disciplinary division at one particular federal agency and then expect to be able to do the type of work you need in order to actually make a difference for that challenge. So the funding resources aren't particularly aligned for some of these grand challenges. That's not always true, but I guess a general statement.
And just to add in, I don't know about that particular study, but to think about how, I like the idea of the public having a voice. How comprehensively are we engaging the public? Are their voices being left out? I think that's really important to consider.
Hi, my name is Tess Edom. I'm from University of Colorado at Boulder. And, we're talking a lot about scientists and what we're kind of expected to do, which, as we all know now, is just about everything. So we're a little bit of everything. We bring in a lot of money to these universities that we're working at, and they create, these beautiful buildings for us to work in, and they take half our grants. But my question, I guess, is, when are universities going to step up and basically, be an advocate for us too? And I know a lot of universities do have, these communications departments that help with that, but, not every university does, and it depends on the university, and it depends on how into it they are. So what do you guys think about that?
So I'm going to go ahead and defend Kate on this one, that every time we have wanted to know, hey, we're writing a position statement about this regulation Immigration and Customs Enforcement just wrote, what's MIT think about this? Or we want to meet this national association, can you introduce us? Kate's always there, the answer is always yes.
So it is a growing movement for universities to be involved in the federal engagement side. MIT has been there longer than a lot of universities, but there's a growing presence for universities. UC Boulder is one of them. I can introduce you to the folks on their team. We're awesome. It's growing. I think it's a good space for more places to be. I once heard Newt Gingrich, of all people, after he was retired, it was just a couple years ago, and he said, when I was working in Congress, I heard a lot from a particular set of lobbyists. You can guess which ones. I did not hear a lot from the science community. And he said, I wanted to hear more from them. You got to have an army to make this happen. You need as many people as you can to be telling these stories over and over again. There's more money in certain types of lobbying than other lobbying, obviously. Science doesn't get a ton of money to be doing this type of advocacy. But we're growing and we're fighting hard, so we're trying, but I agree, the more the merrier in this community.
I think it's easy to, not all times do the university and, for instance, the scientific enterprises efforts line up.
Right.
I would be critical of universities who were calling on a larger, taking a larger piece of grants, a larger overhead, a larger percentage, considering how difficult it is for a researcher to get a grant right now. But I don't work at the university, and so I don't fully understand what their kind of financial needs are. So I think I would be fair to the university, and I think for the most part, and speaking in a generality, they are there doing the fighting, and there are going to be places where your needs and their needs aren't going to directly align, and that's going to be okay. But certainly, I hope you do get connected with the person out in Boulder, and there are groups like the AAMC and the AAU and the APLU, the American Association of Universities and the Association of Public and Land-Grant Universities, that are out there doing very good work on behalf of the scientific community, advocating for them. So be critical, and there's fair space, but you should also know that they do a lot of good work.
And I would also add that I think a lot of the work that they and the societies and others do is not really in the public eye. You know, a lot of this is about, conversations and keeping in touch and trying to be a resource and trying to sort of do, sort of subtle and quiet advocacy. And just because it doesn't make it to the local, campus newspaper doesn't mean that they're not out there fighting it all the time.
But you can help them fight it by going to Hill Days, by writing blogs, by doing all the things that you guys...
I want to help. I want to be there.
Great, yes. Seriously, I'll give you my card and introduce you to Abby Epic.
If the university doesn't do it, the professional society would love to have you.
Okay. Thank you.
Can we take a question over there?
Okay, sorry, I didn't mean to cut to the beginning of the line. I'm Caroline Markoklis. I am very recently a postdoc here at MIT in neuroscience. I have a question about advocating going to the Hill. Growing up, my dad used to do it for climate research, or for climate change and other environmental issues all the time. And so I'd really like to do that myself. And I find that I want to advocate for about 1,000 things, but probably I could talk intelligently about maybe 10. Practically, I feel like I can figure out how to set up these visits. I'm a little concerned that, I'm from Massachusetts, and I'm going to be preaching to the choir, love Elizabeth Warren. If you guys want to address how I can, talk to some people from states that may not agree with me as much, that's cool too. But, how many issues can I bring up? What, if I actually go in there, do I need to have one story? Can I tell multiple stories? Can I leave information on other things I care about? Yeah.
Well, you have to have an ask if you're going to go in and talk to your representatives. So you can't go in too many directions, but make sure you know what you're really in there asking them for, and then message around that, I guess I would say.
And also, you should pick a topic. To get a meeting, a congressional staffer, a member of Congress has 10 staffers, and they have a portfolio of issues. And so the climate person and the research person may not be the same person. So, you're going to get a meeting with the person on the topic that you wanted to have. So channel your energies into a laser beam-like focus on and yes, a specific ask that is, followable and that you can do follow-up on is really, really important. And it's preaching to the choir. The choir still needs to, if they don't need to be preached to, they need to be encouraged, and if they're not encouraged, they need to be thanked, because don't take them for granted. Thank them for the hard work that they do. If that's what your meeting is, it's still a good meeting.
Great. Is there any way to get double bang for my buck and give a handwritten letter or something else while I'm there about all my other topics, thinking about this, how many voices my voices count for, or my things count for?
Now you're getting greedy.
There's so much.
To the extent that you can try to develop a bit of a relationship with the staffer, and try to find other opportunities, if a month later there's a bill coming up on something else that's relevant and you have that connection, you're more than just calling the main switchboard.
Cool. Thank you.
Yeah, unfortunately, I think we are out of time for this panel discussion. I'm going to ask the panelists to hang out so you guys can come up and chat with us here in a moment. I think we need to let everybody else take a break for a few minutes before we go on to our keynote address. All right. One announcement from Kristen before we go.
So we're going to have computers set outside that you can write emails. So if you guys want to use one of our laptops to write an email about the budget, that would be awesome. You can also give us your email addresses if you want to get involved. I know there was a question about how students can be involved, and no one brought up that they can be involved with AFS and with future research. So we're happy to take your emails and let you know how you can get involved. So.
All right, and with that, guys, let's thank our panel this evening.